So thanks everybody for joining us on an impromptu sort of webinar on the first Friday of March. I'm Chris. Joining us are Chris and Simon. I met Chris many moons ago and have chatted about various things over time. And Simon I met a couple years ago at a conference as he was unveiling his project Datasette. And I came across a tweet that Chris had put out back in January or so, talking about how he started to use SQLite as his kind of go-to source for storing GIS data and doing some analysis. And I just come off a QGIS project that was maddening in terms of how many different shape files I had to create as a result, and got interested in it. And Chris actually brought up the idea of doing kind of like an impromptu webinar right around night guard. So here we are. Chris is a journalist developer with USA Today. He's also the founder, along with Laura, right, of Homicide Watch, which was a kind of a cutting edge structured data project. Started back in the mid-aughts, is that about right?
Late to 2010,
okay.
I want to say. It's getting to be a long time ago.
And Simon created Datasette as part of your fellowship, right? With the Stanford Night?
Just before, it was before the fellowship, but the fellowship was the chance to turn it from a sort of part-time side project into something I got to work on for a full year. And then I enjoyed the fellowship so much, I kept on working on it full-time afterwards, even though nobody's paying me to do it.
But I guess we should probably also mention, like, are you one of the co-founders, co-creators of Django?
I'm a co-creator of Django from back in like 2003. Like it was a year-long internship at the Lawrence Journal World in Lawrence, Kansas. And Adrian Holovati and I built this thing that we called the CMS in Python, which after I left, they packaged up and open sourced.
Okay. So like the DNA runs deep in that respect. So yeah, I just want to hand it over to you and to both of you, and just to kind of talk about SQLite, right? Which is a light version of SQL, but the benefits are pretty immense, you know, once you kind of get in and combine some of these tools that you all have created. So why don't you take it away?
Thank you. We didn't plan this very much, but I realized that, is it worth having Simon, do you want to explain Datasette before I get into like all the weird stuff that I'm doing?
Yeah, okay, I can do that.
Jump right into.
I
realized suddenly that
I will do a quick what is Datasette for just to make sure everyone's on the same page. So hang on, I'm sharing a screen here. So yeah, so Datasette is this open source project I've been working on for almost 4 years now, and the idea is the original idea was to make it as easy as possible to publish data online. So when I was at the Guardian newspaper many years ago, we had a thing called the data blog, where we'd publish the data behind our infographics as Google Sheets and stick them on a blog. And I always felt there should be a better way of doing that. So Datasette started as an exploration of what it would look like to publish structured data online in the most flexible way possible. And the datasette.io is the website. The best way to see what it does is to see a demo. So this is a demo which shows, it's a table of 33,000 power plants around the world. So like this one in Afghanistan, this latitude and longitude is a hydro plant and so forth. But where this demo gets fun is it shows off Datasette plugins. This is a visualization plugin which looks for a latitude and longitude column and puts them all on a map. So now we can see a map of all 33,000 power plants in the world once they finish loading in. And this illustrates that the moment you visualize stuff, things stand out. What are these two down in Antarctica, for example, right? This is instantly obvious on the map. Turns out McMurdo Station has a oil generator and they've got a wind turbine down there as well, which is kind of cool. But yeah, so it gives you this, you give it a database, it gives you a web interface for browsing that database, for sorting it, for filtering it. It adds faceting, so you can see, okay, China has 4,200 power plants, Brazil has 2,000. If I click on nuclear here, I see just the 198 nuclear plants in the world. And I can see that the US has 61, France has 19. Click on France, now I'm seeing just the 19 power plants in France. Everything here can be exported, so I can click CSV to get back a CSV file of the 19 nuclear power plants in France. And you can get things out as JSON as well for building for building, for doing in API integrations and so forth. But the key idea here is make it as easy as possible to take data, whatever it is, and stick it up online so people can explore it and they can start writing integrations with it as well. And then a lot of the thinking around this goes into these plugins, where I'm showing you a basic plugin here. Chris has built some really exciting geospatial plugins that he'll be talking about shortly. So yeah, so that's the sort of fundamental idea behind Datasette. It's a web application and tools for creating and publishing these databases. The secret sauce under all of this is this database called SQLite. And SQLite is the database that everyone on this call is using every single day, but you may not realize that you're using it because it's designed to be embedded in applications. It's in my phone, it's in my watch, it's in my laptop. Applications that you use all the time are using SQLite. And the only thing that SQLite isn't usually used for is putting stuff on the web, because it's designed to run on a phone, but it's not really designed to have tens of thousands of people hitting it all at once. Turns out it actually works great on the web if you treat it as a read-only database, right? If you say, I'm just publishing data for people to look at, but I don't want people adding and inserting things, then you can run multiple copies of it and serve as much traffic as you like. And the cost of serving these things is basically nothing, right? If you want to use MySQL or Postgres online, you're going to be spending $10 a month on on a database server plan, if not more than that. SQLite, most of my SQLite projects I host for about 50 cents a month, because you can use hosting platforms like Google Cloud Run or Vercel or Heroku, where you often don't end up paying for like small projects, or you only pay for the traffic that they receive. So this is a really great engine to build this kind of stuff on top of. It's also got, there are extensions to SQLite that add geospatial support. It's got really good built-in full text search. You can do JSON. There's a huge amount of power and flexibility built into this tiny little database and the core idea behind the Datasette project is to take advantage of that and use it as much as possible to essentially almost democratize sort of data analysis. It used to be that you needed a $10,000 a month data warehouse to do like these kinds of queries. Actually, if your data is less than 100 gigabytes, you can run it on a laptop and it won't cost you any money at all. And so I've been thinking a lot about this idea of small data, right? What does a data warehouse look like if it's only gigabytes of data? So you don't need to host it in something fancy. You just need a $5 a month server or your own laptop to start running analysis. So yeah, so that's a initial sort of lightning quick explanation of what's going on here. I want to hand over to Chris because I really want to see some of the stuff that he's been building.
Yeah, thank you for that. Sorry to throw you right into the fire there, but figured before I get into talking about the weird stuff we've been doing, we should talk about the normal stuff. So let me start actually with SpatialLite. So Simon mentioned that the core of this is SQLite, which I have really come to love lately. I first used it probably when I was learning Django, and it was very much a, try things on SQLite locally, but then, as you deploy it, go to a real database like Postgres. And Postgres is fantastic. Like, I don't have anything bad to say about Postgres. But there is a certain mental overhead that I found of like, I would like to do database type things, but I need to manage a server. And maybe I've got this Postgres app here, which is also fantastic. But even just going through the like effort of, I'm going to create a database, I'm going to run migrations on it when I need to change things. I'm going to, do I delete it and recreate it? I don't know. That's a lot of stuff. And because SQLite is just a file, like I will literally create something, didn't like it, delete it, make it again, treat it as a file. And that has been liberating mentally to not be precious about a database. Like, it is a database. It does all the stuff that Postgres and PostGIS do, but it's just one file. So that's been really exciting to try and use. And then it lets you do all the things the databases do. So SpatialLite is the GIS extension for SQLite. It is, as they say, roughly equivalent of Postgres plus PostGIS. So if you, for example, if you read Tony DeBarros's book on practical SQL, and he mentions all the stuff you do in there, all the PostGIS stuff, come look at this. It's awesome. Most of that book is there. And actually go read that book because it's awesome, an awesome book. One of the things I'm going to touch on today is spatial indexes because it turns out they really, really help things out. And they're a little weird, but just keep this in the back of your mind. Spatial indexes are awesome. You'll see what this is. So in my job, I work on a team called the Storytelling Studio at USA Today Network, aka Gannett. And we work on things like this, where people are doing big investigative stories. This was a thing that came out of basically the Western states, Colorado and the Arizona Republic earlier in the year. And we build storytelling tools. And reporters and editors come to us and they say, we have this amazing story, this amazing piece of journalism. We need to work on the presentation. And in this case, they had one of the reporters, Caitlin McGlade, had all of this spatial data about water permits to take water out of national forests, and how that had been mismanaged. And so they wanted to do something like this, which is a lot of fun. This is all Mapbox under the hood. This is actually using a different thing that I built called Ulysses, which is a JavaScript framework for telling these kinds of stories. Set that aside for a moment. But we have all this spatial data, and one of the things that I needed to do before I could actually build a map is just see what it looks like. What's here? And I have QGIS, and I could pull it up in QGIS, and that's fine. But it was a lot of repetitive stuff, and I'm honestly not very good at QGIS, which is maybe why I end up building my own stuff. But it's slow and it's hard, and you can do some stuff in pandas and geopandas and notebooks, and that's cool, but it's hard to share. And so I just wanted to see okay, tell me what the data looks like. What's here? Give me a quick shot. And so I wrote this plugin called Datasette so to do that, I needed GeoJSON. And one of the things I needed to do was load it into a database, sort it, filter it, slim it down, export it, or take it from a shapefile, do all that. And it turns out SQL is actually a really good language for sorting, filtering, transforming data with thought. And as much as I like pandas, and I don't really like R, but some people like R, SQL is part of what I like about SQL is that it's just old. It's old, it's boring, nobody owns it. There's a million implementations. There's a million tutorials on the internet. And so I can just write queries. And so Datasette has, as Simon mentioned, all of these plugins and this sort of plugin API, which let me do things like this. So the first thing I wrote was Datasette GeoJSON, in part because I had gone to Simon and said, can I take SQLite utils, which is the other, so there, actually, sorry, let me back up a bit. The way I tend to get data into a database is this library that Simon wrote called GeoJSON to SQLite, which does exactly what it sounds like. It takes GeoJSON, loads it into a SQLite database. Cool, I've got it there now. Now I want to look at it, or at least if I can write a query, can I export it? And Simon said, actually, why don't you go look at Datasette and export it from there? And so I wrote this, which adds, it's actually a really small plugin. This is all the code. And tell me if I'm talking too fast. And it basically says, can you render, do you have a geometry column? If so, turn this into GeoJSON. And so basically now any query that does that gives you any query that has a geometry column, it tries to return it as GeoJSON. And then because that was available, I took that and wrote Datasette GeoJSON map, which says, okay, if you can render GeoJSON, take it, and render it on a leaflet map. So I'm going to try and ignore the red numbers on the chat here. So that got us a long way. So I'll show you just what that looks like here. So I took, if any of you know All the Places, it's this amazing scraping project where people take anything with a store locator and write a script for it. And so here are all the things. I decided to earlier this week to load that into a database. Again, on a whim, because I was like, it's easy to put it into a SQLite database. Let's throw it in and see what's here. And here's all the things that they are scraping.
Could this answer my long desired project to find out how many CVSs and Walgreens are across the street from each other in the United States?
Probably, yeah. I think is
oh, that would be so much fun, because you'd have to do it with you'd have to do it with proximity, right? You'd have to say everything where a CVS is within 250 meters of a Walgreens. I bet you could do that with SQLite. It would be not completely trivial, but totally feasible.
Look at Canon too, the K nearest neighbors plugin. So yeah, here's all the things they have. It's weird. You'll notice that a lot of my demos use in and out locations because I'm from California and in and out is the best. So if I were to take all of those and then ask a question, that's getting ahead of ourselves. I can then map it. So I can, and I've loaded in some other things here. So like if I just want to see all the states. This, by the way, is I loaded this with the LA Times census data map, census map downloader, which is another awesome project. These are all linked in the README over here. But so here's just a quick example of if you have a geometry column, it makes a map. And it just puts all the columns in the pop-up. And this is really what I was initially looking for. Like somebody hands me a data set, they hand me some GeoJSON, can I just see what's here, click around, do a quick filter. And I can do, what state is number 13? It's Georgia. Cool. Like, that's not very exciting, I'm sure, but think about it. And so you can start then. So as I was doing that, one of the things I said is, let's do, Mapbox years ago made this thing called simple style, which is a way of saying, if you put presentation information, fill color, marker color, whatever, into your data, into the JSON properties, you can actually style the map that way. And so I decided to have a little fun with this. And I live in Boston. So here's Suffolk County, and here's all the Dunkin' Donuts and all the Starbucks. Dunkin' is in purple, Starbucks is in green. And so this is a map with a SQL query. And that's, this is a goofy example that I'm sure is not, not the most important thing in the world right now, but it's fun and it was fairly trivial to generate. I live over here, if you're wondering. This is all the touristy areas and all the high expensive office buildings. And this is where Boston College is. So if you're wondering about that. Yeah, so
can you scroll up and just pause on the SQL query for a second?
Sorry, this is a gnarly looking SQL query, so take a minute to absorb this. Yeah,
I love the SQL query so much. There's so much going on in this.
Yeah, I feel like I should add comments and annotate it, but I haven't done that yet. So I'll tell you what's happening. These are like some of these things I never did 2 weeks ago. This is actually just doing this has been a remarkable learning experience. And this is also published on fly.io, which I just tried out also this week, and it's great. So shout out to publishing plugins. Look at those. So here's what I'm looking at. So I'm selecting various things from my places table. So I loaded these in. Let me actually show you just one more view of this. So I loaded in places as JSON. That is a way you can do this. Normally, these would all get converted into columns because this is lots of store locators for everything. And certainly CVS and Walgreens aren't going to agree on a data form on what fields they have on their store locators, and CVS and In-N-Out are really not going to agree. So I loaded these all in as a JSON object, just a blob. So this only has 3 columns: ID, properties, and geometry. SQLite has amazing JSON support. And actually, it just got better in the last release. So this is on a slightly older release. But if I were doing this locally, I'd use the new syntax. You can actually use this new arrow syntax. It is very similar to Postgres, which makes this just a lot nicer to look at. But so I'm using this JSON extract function on places.properties, pulling out the spider name as type. So that's Dunkin' or Starbucks or Caribou Coffee. There are no Caribou Coffees here. I'm pulling out the address. I'm pulling out the website. Those are just sort of, I was curious. Places.geometry, so we can map it. And then here's where I'm getting into the actual styling of the map. So I'm doing things like this. So I'm saying small as marker size. So if you set the marker size, it's small, medium, or large. So if I wanted giant markers, I could do that. Cafe is a marker.
What are the brackets doing there?
So that is a way of quoting column names. So marker size hyphenated is not a valid SQL column name, but the bracket tells it, treat it as a string.
Cool.
Which is another thing that I learned, fairly recently. If it's not obvious, I am not a SQL expert. SQL is one of those things that I wish I had learned 10 years ago. And I really didn't start taking it seriously until I read Practical SQL and then started using SQLite a lot. And it's been great. So the next thing is where I'm actually choosing colors. So I am running a case statement on the spider and saying, if it's Dunkin' Donuts, make it this purple color. If it's Starbucks, make it this green color. I pulled those off of Color Brewer. I don't do colors. But then this as marker color. And so that tells it, if you look down here, the column is, so the type gets here. The column is marker symbol, marker style, marker color. And so you can start.
And those marker column names are just like special names that Leaflet will read in and render.
So yeah, so simple style. It's a Mapbox thing. I will come back to it. GitHub supports it. This is actually the where's the spec? Here it is. It hasn't been touched in 5 years. It's very minimal.
Gotta pay your bills.
Yeah. But like it's it does what it needs to do. So it just talks about if you put these things in your properties, the map will show up like this. Leaflet doesn't implement it out of the box. I use a plugin, but it's a fairly simple implementation. If you're using the Mapbox Leaflet plugin, Mapbox JS, not Mapbox GL, it'll use this. I don't know if Mapbox GL will use it, but if you put GitHub actually supports it, so keep that in mind. I'll come back to it. So yeah, but you can do things like that. The other thing I did is, so let me go through this whole query, and then I'm going to jump to another data set. So yeah, here's where I'm getting my data from. I have places, I have counties, and then I am doing my very complicated where clause, which is I'm pulling out the spider name again. I probably could have just used type, but where it's in these, where the county is, this is Suffolk County. I live here, but I still have to look it up. Within is just a normal SQL function, point and polygon. And then this is the spatial query. So this is, I will actually edit the SQL just because I want to show you how much of a difference this makes. So what this is doing is it's saying, find the row ID, which is like the weird magic SQLite primary key that everything has, is in this, the result of this nested subquery. And this subquery is saying, give me all the rows from the spatial index, which is sort of a magical keyword. Spatial indexes are virtual tables that use, what do they use?
I think it's R-tree indexes.
R-tree, yes. Thank you. It is an R-tree index. So it is sort of like a table, but it doesn't really exist on disk. I have not looked into how that works. But where you say, from this table where the search frame is counties.geometry, and it will say, okay, so I'm looking at this county. I'm going to drill down to this, and I'm going to use that as my R-tree, and very quickly filter down a list of possible things, possible features which are inside that. And then I'm going to do it. So you can actually look at the query plan too on this and see all the things it's doing. And it's remarkable. So here it's taking, this takes 77 milliseconds, which is pretty fast to look at a million.
It's over 1 million rows, right? There's
Yeah.
1.1 million rows in the places, and it's doing that point and polygon lookup. So
in a,
get that done in 77 milliseconds is it's pretty impressive.
Yeah. And so let me just take this off and run this again. And this, okay, didn't time out. That's good. That's almost 3.5 seconds without the spatial index. And so that means what this is doing is it's looking through it's probably looking through every row in that million rows and saying, is this in the polygon? Which honestly, to do that in 3.5 seconds is pretty fast, but it's not 77 milliseconds. So
which
like,
fly hosting package are you using for this? Is this their cheapest one?
I hope it is. Yeah,
brilliant. That's like, well, I think you're within the free tier, so this shouldn't cost any money. If you weren't, it would be, I think, $4 a month, I think is what Fly charge for that one. Yeah, I don't know. I just signed up for it this week, so we'll find out. I'll tell you in a month what it costs.
Hey, Chris, Michael has a question I think he wants to ask. He posted.
Yeah.
Yeah, Michael, do you want to go ahead and ask?
Sorry, I'm watching your cursor move and I'm like, where's the mute button? So I've been peppering the chat with a variety of comments, but are you talking about the load as JSON with Pydantic question, or the bidirectional parsing of like getting SQL into the Python and Pandas worlds?
Either one, sir.
Yeah, so actually I'm presently working on a project which is using Pydantic, and it's driving me nuts because there's the JSON world, there's the Python world, and half the time you need to convert things to dictionaries to sort of talk JSON, and the other half the time you're working with models that gives you stuff that looks a little bit more structured. And the code that I am working on didn't really come with a great articulation as to what's home base, and so stuff is constantly flying back and forth between the two and converting from one to the other. And without getting into all those details, what I sense from the domain space of this particular cooking show is that having a database that just allows JSON to stand in and not get all perturbed by columns prematurely could really sort of simplify how we talk to our data scientists about just hold it in JSON and just convert it to Pydantic when you do the model
Yeah.
conversion, and don't get all tied up in the SQL column. So I'd love to explore that topic a little bit.
Yeah. So this is a new thing that we just put into, so talking about just importing, where is it? There it is. New feature, which I hope I actually wrote the documentation for. Properties. Okay, so let me actually show you guys the make file that I used to load this. This is all the places, yeah. So loading is a great question. So here's, I love make files. Go read Mike Bostock about make files. Another like thing from the 70s that works remarkably well and is durable. And you know, our friend David Eads calls this cast iron coding. It is things that get, the more you use them, the better they get. And that is Make, that is SQL, that is SQLite. It's these things are built to last, and they're like, you know, they're good, they're tough. So here we go. So here's how I'm loading everything, by the way. So I have, this is the state's GeoJSON file. This is the county's one. Again, I'm using the LA Times census map downloader. Again, shout out to them, it's awesome. Here's how I'm actually building the database. Oh, and then update, which I should actually move higher, is just grabbing this file. So this file gets downloaded. This is the big tar file from all the places. It gets downloaded, unpacked, updated, delete the empty ones because there's a bunch of empty GeoJSON files. And then I'm loading it in, creating the database. I'm being more explicit than I actually need to be here. Just to create it, and then
that's a cast iron coding technique so that when people go and add random features, it doesn't break your stuff.
Yes, that's the idea. And so when I run make build, it's looking through that folder full of GeoJSON files. It's running xargs over it. And then for each one, it's loading it into this places table. And I'm using two flags in here. SpatialLite tells it use SpatialLite. Don't just store it as, you can store JSON as text and it's fine, it'll work. But if you want to do all the fun point and polygon stuff, you need it in binary. SpatialLite has this weird internal binary format. Don't try to parse it, just let SpatialLite do its thing. And then so this properties flag says, don't break the columns, don't break each property out into a column, just keep it all as a bundle. And so that this data set actually inspired that, because I was trying to load it and with alter columns and it kept freaking out, and I ended up with this table that was 100 columns wide because lots of things have one feature, and it was a mess. And so this basically treats it as a document store.
I'm just going to call out that Chris is an excellent open source citizen. A whole bunch of the stuff in here are things in tools that I released that he added features to. So he's responsible for the SQLite utils in its SpatialLite option, and for GeoJSON to the GeoJSON to SQLite having dash properties and so on. I think he's got code in 4 of my projects as just over the past 3 or 4 weeks.
I'm more to write, I'm sure. But yeah, this has been really useful for me over the past year, so I'm happy to keep giving back on these. So yeah, this will bundle it all up, and then I'm using this create spatial index, which you can actually do here in one step, but again, I'm just breaking it out. This will also, if it already exists, it'll no op, so that's there. I've never heard of Trino. Yeah, so that's the import. Let me get into Let me show you one other data set, and then I'm going to get into exports because that is also important. So I wanted to, sorry, are there any more questions on this data set before I jump over to earthquakes?
Can I ask you one real quick question about the JSON extract function?
Yeah.
Is that something you have to install, or is that something that's built in, or how do you access
This is,
that?
it's built in by default. So, and it has gotten better. So this is all the functions that are in as of the version of SQLite that just came out like 2 weeks ago, a week ago, I think February 22nd, however long ago that is, a week ago. This is installed by default. So it used to be something that you'd have to compile in, or you could optionally compile in. I've always, every version of SQLite I've used has had it compiled in by default. The version that comes with Python seems to be. I recommend, and this is very much a side topic, but installing SQLite with Homebrew and then telling Python, especially if you're using PyInf, to use that version. There's some weirdness around that, but it is actually documented.
Also, Homebrew update quick, like the new version of SQLite 2 weeks ago, it's in Homebrew and you just get it, which is awesome.
Yeah, I actually had to backport some of this to use JSON extract because the new stuff isn't in the version that is in the Docker file yet. But it's fine, like it all works. So the new hotness is these arrow operators, which lets you just write like this, and you can just say, I'll actually do it. You can turn these into, instead of doing JSON extract, you just say properties arrow at spider or address full or whatever. You don't need the $sign. You can just, it actually is very nice and very quick to write. So yeah, put that in. I'm just gonna throw that in the chat.
Maybe Brian, I think, has a question about using the properties or adding JSON if he wanted to ask quick. I know Simon, you just kind of responded to.
Yeah, there was a question in the chat about are there any disadvantages to jumping JSON directly into SQLite instead of making actual columns? Slightly. Oh, go ahead.
Yeah, so I just discovered this. This is very new. SQLite has generated columns, which are virtual columns, and you can index them. So you can use this with JSON. Let's see if I can find the post real quick.
Oh, that's cool.
Here it is. This. I haven't actually made this work, but this looks very slick. So basically you tell it, take your column that you're extracting from JSON, keep it stored as a virtual column, and index that.
Will that update on updates?
It should. Like I said, I haven't made it work yet, but should.
Also, it's SQLite. If you need to update, just make a new database.
Yes, I literally did that. Like when I tried this out with my million-row database, I just did, copy all the places to all the places .backup.db, and then
run it again.
Ran it on this, broke it, copied it back.
There's a great workflow you can do with SQLite JSON where you dump literally gigabytes of JSON into a bunch of rows and then start iterating the database structure by writing like create table so-and-so as brackets select JSON extract XYZ. And you can just keep on going and use SQLite's extraordinarily fast at parsing JSON. So you can churn through gigabytes of JSON a second and just keep on creating new tables and then dropping them and then creating them again and sort of figure out your schema that way.
Yeah, it's remarkably cheap to iterate on this. Yeah, so what else on this? let me move on. So I want to talk about this. One of the things I did as I was preparing for this is I started looking through other people's NICAR mapping tutorials, and Peter Aldis has this awesome R tutorial on using seismic risk. And if you like R, go check this out. Peter's a great teacher and super smart. And I think actually teaches a science writing class at UCSC with my old journalism teacher. So that's cool too. So he did all this stuff where he geocoded things and had this made this map of spatial risk or seismic risk, which I'd never seen before. And so this was fun. And I said, well, what can I do with that? And so I grabbed it and I put it in a database. And I said, well, let's just map it. Actually, so one of the things he had in there is countries from Natural Earth. And I said, well, let's load all those. And I started noticing there's a label field in here for colors. And I had written this color brewer function, which takes advantage of one of the great things about SQLite and Python is that you can write Python functions that operate inside your database. And so this is SQLite color brewer, which is very small. I will show you the entire code base. Most of it is just turning color brewer JSON into color brewer Python. And then this is it. It's just registering this function. And it works. If you have Datasette installed, it automatically registers it as a plugin. If you don't, it's here to use with normal SQLite. So you don't need Datasette with this, but it'll work. And it just gives you this function that takes three inputs: what color scheme you're using, what's the length of it, which varies. If you know color brewer, it's anything from like 3 to 12, depending on what you need, and then which actual number you want. And so you can do things like color by number. And so these map colors there are 9 variables. These are 1 index, so I'm subtracting 1, and I'm just saying, give me the categorical colors, 9 of them, call that the fill column, and that gives you this. And so if you want to, I defaulted it to Asia. I can type. Let's look at Africa. Here's Africa colored. Here's North America. Cool. So that's, again, sort of a toy example, but it gives you a sense of like what you can do with this, and also the perils of Mercator. So let's take seismic risk. This has a value range. These are strings, but there's only 5 of them. So we just another case statement. I'm not doing any joins. Here's the equivalent of Peter's map of seismic risk. Shout out to Oklahoma and your fracking. This is where I grew up. This is where all my relatives live. So in the spirit of not being too much of a downer with this, I decided to go back to my favorite data set, which is all the in and out locations. And I joined it up to that, using another spatial index. Again, speeds this up by an order of magnitude. Here is every in and out location in the country, colored according to its earthquake risk. Texas, you're fine. Colorado, you're great. California, you know, at least you have the best cheeseburgers in the world. So, you know, look through it. Ooh, this is really lagging with the Zoom. I've been to most of these. This one here in Salinas is great. So yeah, this is, again, it's doing that with inquiry. It's getting these two tables. It's doing the same spatial index pattern.
What is the within necessary if you're already doing the spatial index?
It is, yes, shout out to Animal Style. I'll show you what happens when you take it out. I will be real honest and say I don't understand everything that's happening under the hood here.
My understanding here is that spatial indexes do boxes and that's it. So if you ask it for everything in the spatial index for, is this the county that we're looking, oh, for the rest, you'll get everything within the square bounding box, but it doesn't go down to the detail of the shape. So it's a way of, the reason it uses it as an index is it knocks down everything from 1 million rows to like 10,000 likely rows, and then you do the more expensive within calculation just on that subset.
Yeah. So apparently, if you don't have the within,
is like, yeah, it's like scoping it to a certain sort of coarser, but still smaller.
And it turns out the within is what actually does the join. So it doesn't know which seismic range you're in if you don't do the within.
Right.
And I'll show you just how this spatial index speeds this up again. So that was 600 milliseconds. This is a smaller data set, so it's not as dramatic, but this is 126 milliseconds. So yeah, it's pretty quick.
There's a sort of a key idea within Datasette that this really illustrates really nicely, which is that Datasette lets you build interactive applications as a bookmark, right? This is this SQL query. Chris figured this out and wrote it down and made it, but now you don't have to know SQL to follow that link. So if you're working in a collaborative newsroom environment, you can ask for a thing, and there's actually at the very top of this page, there's a hide SQL button that you can use just to make it slightly less intimidating. And so now if you share that with somebody else, they can still get the data out to CSV or whatever. You can add parameters that show up as additional form fields. But essentially what you've done is you've created, in this case, an interactive application that shows you seismic risk in and outs. And you didn't have to write you wrote some SQL and then you bookmarked it and shared that link on Slack or whatever. And that, I think, is a really interesting way of essentially building these sort of ad hoc applications.
Yeah, and that's actually been one of the ways that I've been using this internally. So Fly is amazing, again, for deploying, but for like internal stuff, we have Kubernetes. And so I will throw this on our like dev Kubernetes cluster, which is not a thing I ever thought I would say casually. And, you know, working on this story, I literally was like talking to the reporter who's based in Phoenix and saying, hey, does this look right? Does this, you know, is this the subset we want to show for this view? I wasn't able to color code it at the time. I hadn't written any of that yet, but just being able to say like, I want to highlight these. Actually, I was doing it with this one. Like, I need to highlight this set of boundaries. Actually, we're really working on this part. This is the continental divide. Turns out everywhere west of here is losing water. Everywhere east of here is gaining water. Climate change is real and it's bad, folks. So like that was really useful, just be able to say, is this right? Am I understanding this right? Am I doing this? Am I getting the right subset here? Am I doing the math right? Because the math behind this is complicated. And so that ended up being incredibly valuable to just, and like I sent her the thing and said, check my math, mess with it as you need to, send me back the query if it needs to be different. So yeah, and then part of my workflow is I will, anything that I need to come back to, I will stick it in canned queries, which is another great feature of Datasette. So inside metadata, you have this queries parameter, or this queries field. So all the places the database, queries is any canned query. So anything, these all show up. So that's what these are. These show up down at the bottom here.
Does that YAML file just live next to the database? So when you run serve dataset, it reads
yeah.
it?
Yeah, so what I'm doing, so in my make file, again, I make everything. I have this make run, which is just because I don't want to write this. I don't want to type this over and over again. So dash M or dash metadata will tell you where to find your metadata file. It can be JSON or YAML. I always do YAML. I have some settings here. I have a loading extension. But yeah, so I just type, I just run make run. I do this mostly locally. I almost never deploy anything. And so I just do make run and I change things and I start the server. But then sort of anything as I'm going through this, I'm like, oh, I want to tweak that query. You know, copy the SQL. I just, you know, whatever I edit it, copy. It's cool. Edit it, paste it in here, and then save it, and then I have it. And so that is, again, like you can even see the earlier version. Like I did this first just with using a light query and not doing any spatial stuff. This is slow as hell. This is very fast. But I just copy and paste it in, and that's great. And then I have a link to it. And so the link, this, like that's an easy link to just chat to somebody. Like that's not a gnarly SQL query at all. I can hide that again. Like somebody can look at that and be like, huh, that's interesting. All the Starbucks are where the tourists and the college kids are. Cool.
We've got 5 minutes left, so we should probably just go to more questions. I guess.
Let me show you one last thing, just because this is actually really useful, is you can then export these. Here's how I export them. It's in the make file again. I write things like this. So this --get will get a URL because you have JSON, GeoJSON. You get that. I'm just writing it out. I have an exports that just says get me all of those. And then remember how I said GitHub supports this? Here's a static version. Ta-da. And so now I'm done. But that was the last thing. Because exporting is like, eventually you want to take this to like Mapbox or D3 or something to make it nice and add a legend and add whatever. But this is a file that is ready to go.
I dropped a link to that, your make file in the Google Doc. So that's down here.
Yeah.
Along with so those others make resources you shared yesterday. Yeah, well, there's questions. You can just kind of unmute and start asking.
Is anyone using, this is related, but I guess a little bit of a new direction. Is anyone using the GitHub Flat project for anything? There's a little bit of overlap just between like static data querying and what's going on here.
So I was, I've been talking to GitHub a bunch about that project. I'm not using it myself, but one of the things they give you with that is a really good like JavaScript CSV navigation type thing. But I think the most important thing about that project is that was GitHub saying it's okay to keep data, CSV files, JSON files, all this kind of stuff, it's okay to put that on GitHub. Because I was a little bit nervous when I started doing that, that it felt like it might be outside of the spirit of what GitHub want you to use their platform for. No, it's completely, GitHub are totally fine with you sticking a gigabyte of JSON in a repo. If you get above I think above 2 gigabytes, they might send you an email and ask you to stop.
Yeah.
But you can do a lot of stuff with a gigabyte of JSON or CSV.
I hit a limit on that trying to download all the wildfire data in history, and that got excessive. But if you're under that, go to town.
Yeah, I'm using Git scraping now to track crypto prices, and I think I blew the limit on that pretty quickly. For work, please.
Simon, you mentioned the plugin nature of Datasette, and you also mentioned the idea that you can build standalone applications. Does that mean, in theory, is it like a charting option similar to the GeoJSON map a possibility?
There is a charting one. It's called Vega.
yeah.
It's actually one of the earliest plugins I wrote. It's okay. I want to build a new one on top of observable plot. But yeah, the principle here is that any visualization you can imagine, somebody could write a plugin for. And this is one of the things that so excites me about Chris's work. His GeoJSON visualization plugin is the first visualization plugin that I didn't write. And that's the dream of plugins, right? Is you can wake up one morning and your software has a new feature and you didn't even have to review a pull request, right? It emerged into the world fully formed. So I'm really excited to see more variety in visualization plugins as more and more people get involved with the project.
I was also just looking at data at observable plots, so we should talk about that because it looks very nice.
Observable plots really impressive, yeah.
Yeah, and I think also it's worth saying that like Datasette should, and I think does play really nicely with observable, because all of these, like,
I do a lot of my visualization work in observable notebooks, pulling JSON from Datasette, and it works really well.
Yeah, you can also upload that SQLite file directly or use, the Datasette JSON API.
Yeah, like you could just fetch this. This should have CORS headers, or if it doesn't, it can. And it's, it's there for the taking. What else?
I'll just say that one of the reasons I came here is because I'm working on a project where our goal is to make it so that people can treat data more like code. So in the world of ESG climate stuff, there's so many people trying to get data conformed to their central repository, and everybody's duplicating the same sort of effort. And one of the things that's kind of cool about Datasette is you bring the database to your data, and getting people to sort of flip their thinking about how can I coordinate data sets as opposed to how do I coordinate data.
A great feature of that is, so everyone has a slightly different idea of what shape their data should be. Once you've got it in Datasette, you can write a SQL query that says select title as name, comma, lat as latitude, comma, LNG as longitude, and then get back CSV or JSON in that format. So it also it basically acts as a ad hoc conversion engine between different formats, which I think is really powerful for that kind of thing.
Yeah. And I use that all the time because people send me, things that have field names that are that long, and I'm like, I need that. And like, it's not a headline feature of SQL, but it's really useful.
Yep.
I think that about puts us at time. I don't know if anybody has any other questions you want to bring up before we sign off, or if you want to add them to the Google Doc. I guess, Chris, Simon, last thing is, if folks have questions or they want to, ask for advice or just have a technical thing, I don't want to offer you up as tech support, but pull requests, Twitter, Slack.
Twitter, definitely. News Nerdery, we're on the News Nerdery Slack. Datasette has a discussions forum on GitHub. And also, if you want to talk to me one-on-one about this, I run an office hours thing every Friday where you can grab a slot in the Calendly, and I'm always, the problem with open source is no one ever tells you what they're doing with it. So I'm always desperately keen on talking to anyone who's using this stuff or who's interested in using this stuff.
I'll find a link to your office hours link and drop it in the Google Doc.
Yeah.
Thanks everyone for coming. Thanks, Chris, Simon, for your time and running us through all of these kind of fun laboratory experiments. I just switched our metaphor from cooking to lab experiments, but oh well.
You know, sometimes they're not too far apart.
Yeah, good seeing some familiar faces and some new ones. Thank you all and enjoy the rest of your Friday.
Thanks. Bye.
Yeah. Happy NICAR, everyone.
Yeah.
Thanks, guys.